deduct three marks for poor handwriting. And so the total was around 97%. So it's easier to get higher score. Please do not try and destroy my reputation. So far, we've not had any fails in the course, which is an exciting news for all of us. Like I said, it's not that difficult, okay? If we try as much as possible to follow every lecture. Mode of communication, mostly on the LMS, since we are not based on campus. So if you have any challenges, the LMS, you can, there will be forums created there for you to put your questions and your suggestions or even your recommendation over there under the topics. You can also reach me on either WhatsApp or Telegram. So if you have any question, I am stuck over here, I'm going through this, I'm stuck over here, can you walk me through it? Then I'll be able to do that. Phone calls, mostly not possible because sometimes you'll be in a meeting. But if you send your question via WhatsApp or Telegram, it's on quiet or on silent mode. So I'll be able to address your challenges. So let's try and limit ourselves to the Telegram as well as a WhatsApp message. Like I mentioned, assessment is 40% for class score. That includes your online presence on the LMS, your participation in class, for example, like today, your attendance as well, and then all the quizzes that will be taken as time goes on. And then the 60% is the end of semester examination. It is easier to get A. So please try as much as possible to follow due process so that we can all pass and pass very well and then leave. Once you get the course outline, you will notice that the subjects or the course itself has been divided into tiny sub-modules. And so we'll be going according to that structure. But most importantly, the way we are tackling the calculus is the applicable side. And that is how come the lecture videos have been made available to you. We're also not restricting you to only the GCTU lecture videos, but also any other learning lecture videos that you can find. These days, there are several lecture videos available, irrespective of the course or the subject that you are taking. So please make good use of that. And we also disadvantaged in the sense that we are not on campus for you to walk in the office and then ask questions. So let's try as much as possible any available resource or time that you have, make good use of that, okay? Because it's difficult when you're outside campus. It's way easier when you are on campus. But with globalization of education, you don't necessarily need to be on campus. You can get information, access to information, irrespective of where you are. There is going to be a lot of group work, and there will also be a group presentation. So group work and some group presentation. And the presentation, everyone will talk during that day. It will be a topic that we'll pick, and then we divide ourselves into groups, and then you do extensive research on the topic that you pick. It will be a balloting. So one person from the group will pick a topic that will be for the entire group. And then you do extensive research on the topic, you come and do a presentation on it. The presentation, no one is going to be a secretary, no one is going to be, I am the one doing only the introduction. No, we've all paid equal amount of fees. Therefore, your presentation should be something related to calculus itself, whether it's application aspect that you're talking about or whether it's some rigorous mathematics that you're doing. It has to be some math base. And this is because we want to encourage you working in groups. You get to experience other people's behavior, because once you graduate, you are not going to work independently, whether you are going to create jobs as an entrepreneur or whether you're going to join an organization as an employee. You are going to work with various behaviors. And so once you've been able to work with other people in the university settings and adapt to different behaviors, once you go out there, everything becomes easier. And also because there are some subjects or some courses that you might be lacking. And so if you start working in groups, you understand the various strengths and the various weaknesses within the group, and then you can help yourself. In the university, we don't do individual work. I'm covering my work, don't copy from me. We do a lot of group work, a lot of group discussions, so you can learn a lot from each other. So there will be a lot of group work. There will also be some individual quiz on the LMS as well. So as time goes on, we'll be learning about the rules and regulations of the course as well as the program itself. So let's not worry ourselves so much on that. With that being said, let me ask, when you hear of the word calculus, what comes to your mind? Is it, all right, let me give some option. Is it fear? Is it confusion? Or is it excitement? I know a lot of us are math phobia, but when you hear calculus, what comes to your mind? Some of us, this is the first time that we're hearing about it. But those of us who this is not the first time, what comes to your mind when you hear the word calculus?
Real fear.
Real fear. Hush.
Confusion.
Confusion. Okay, so
Yes,
that's
madam.
Panic.
Confusion.
you
Panic.
start panicking.
Run away, madam. Run away.
Run away.
Complicated.
Complicated. Okay. Okay. All of these are understandable. And that is because so far our approach towards mathematics has been the fear approach, has been the non-understanding approach. It has been, they ask you to do all these complicated mathematics without showing you the meaning of what you're doing. And that is how come the fear and the complication and the confusion comes in. But we are going to, like I mentioned, we're going to take a different approach so that whatever math aspect that we do within this semester, you know that this is what it represents. If you know what it represents, if you know who you represent or what your values are, what you represent, whatever you do, nobody can shake you up because you understand what you represent. All right, nobody can change your perception. Well, there are some cases where you need to take other people's perception into perspective. All right, and so if we understand the whole structure from the layman's perspective, and then understand every aspect of it, all right, not with the mathematics, but see it as if it's something that is part of our daily activity. This way, it will be easier. That is how we can approach the study of mathematics, so to make it easier on ourselves. If you are treating mathematics as just an academic course where I need to choose some formulas and then go and pour it in the exam and then pass and go, then every single time mathematics or even calculus itself will be difficult for you. But we are going to change our approach this time and understand every single aspect related to our day-to-day activity or day-to-day life or scenarios. That way we'll be able to appreciate the mathematics when it comes along. Oh, so this is what we've been doing this so far. That is what we are going to do this semester. So yes, your confusion, your fear, your panic, your runaway, it's valid emotion. So let me not put that aside. But I'm here to tell you that it is the fear is based on the fact of the fact that your approach or the way you are taught mathematics is quite different. So this time around, we are not going to use the same approach, but we are going to use the application approach. This means that there will be a lot of discussions. All right. So it's not just find this and find that, but after finding what does it represent in IT. All right. So there are various ways that we can apply calculus, but this time around, we are looking at calculus from the IT perspective so that you know that this is what it represents in your field. All right, now, are there any people who want to want future career in modern IT or modern IT careers? For example, do I have AI people here? Do I have fintech people here? Do I have people who want to work in cybersecurity here?
Yes.
Yes, we have them here. Okay, what about in telecommunications and network?
Everything, madam.
Everything.
Yes,
Go
Everything is
madam.
included.
everything possible. All right. So
Everything is included. Everything is needed.
all right. So if you want any future career, all right, in modern IT careers, then calculus should be your foundation. All right, any modern IT career that you can think of, or anything you mentioned, calculus should be your foundation. And this is because, yes, and this is because of what calculus represents. Calculus is anything at all that deals with change. So when you hear the word calculus, you are looking at any scenario, any entity, anything at all that deals with change. That is what calculus is about. This morning or up to now, you've done a whole lot of calculus without you realizing that you've done calculus. And that is because your idea of calculus is that I need to have some variables and then introduce some weird signs and weird symbols. That is what calculus is. No, calculus is any activity you perform that deals with change, any behavior that you have that deals with change, anything at all you can think of that deals with change. That is calculus. Let's take, for example, we are not in political scene here, all right? We are not in political scene. We are in IT. In the political scene, at the end of every 4 years, we change our governing body. All right, we go to the polls, we vote, and elect a new governing body. That is calculus. Anything at all. So when we are thinking of calculus, we are looking at scenarios that deals with change. Now, let me ask, in IT, what are some of the things, all right, in Ghana, let's restrict ourselves to Ghana. What are some of the things that change fastest in Ghana today? Are there anything in Ghana in terms of IT that is changing? It changes a lot.
Mobile phone.
Very good, mobile phone. And
Technology.
most technology itself, all right? Technology itself is changing. Those days, if you want to send money to your parents or you want to send money to somebody, or even if your parents want to send money to you, they will have to travel all the way to campus and then give you the money. But these days, thanks to mobile money, so Momo transaction, all right, has come in. So technology itself has changed. Is there anything else that is also changing?
Yes, price of fuel.
Transportation.
Transportation.
Price of fuel.
Price.
Yes,
I
every day
see.
is changing.
A price of fuel is also changing. Okay,
Yes.
How to send messages?
something else is also changing. As the class is ongoing, something also changing.
Sending messages to first before
Madam,
you need to travel before
Okay.
sending the message or
Yes.
delivering the message.
So
Our
let me
means of communication and
Network, madam, network.
very good. So your
Climate change.
Madam, security.
Security, very good. We'll get there. So your data usage is also changing. Before you started today's lectures, maybe you had about 10 gig. Now I'm sure if you check, the amount has gone down. So there's also change in the amount of data that you've used. Any other? The fuel pricing has changed.
Exchange rate.
Changing.
Exchange rate.
Exchange, very good. Exchange rate. So those that are going to be in the forex trading, yes, sometimes the city is appreciating, sometimes the city is depreciating. So that is also calculus. All right. Any other?
What about education?
Phone batteries, our phone batteries.
Our phone battery, yes, is also changing. Any other?
Education.
Sorry.
Stock market.
Very
Stock market.
The e-commerce, yes, I see the e-commerce people. So the banking, has also changed. Our banking system has also changed. Now,
Location is
transportation, very
Hospitality.
Our age is changing.
Our age is changing. Very good. So we are
always trading.
all right, please, if you are done speaking, then you mute yourself so that I won't hear myself again. All right, so those in forest trading, that is also changing. Any other?
Education.
Maritime space.
Our
Maritime space.
yes,
Maritime domain.
yes, that is also changing. All right, so let's take some of these changes into perspective. If we can understand all the various changes that happens in our technological scene, then once we start with the calculus itself, we'll know that this and this is what we are looking at. So let's start with some of the things that you mentioned. Do we know how you notice that if you want to move from one point to another point, whether you are walking or you're using your bicycle, logistics, all right, whether you're walking, whether you're using bicycle, or whether you're driving, how is, sometimes when you're about to start, you want to use GPS. GPS tells you that this is how long it will take for you to move from your current position to another position, maybe 14 minutes. That is how long it will take you. You are walking. But sometimes you realize that as you are moving, your estimated time of arrival, which is the ETA, moves from that 14 minutes to maybe 18 minutes. How do you think the GPS is able to recalibrate that? How do you think the GPS is able to reevaluate your ETA to that 18 minutes? Or even some cases, it says 14 minutes, it will take you 14 minutes when you're walking. But instead of walking, you decide to jog or you decide to run. The 14 minutes will no longer be 14 minutes, but it will be reduced. How do you think the GPS is able to do that?
My calculation.
Recalibration.
All right, so how is he doing that? What is he using to do the recalibration?
Satellite zeros and ones.
Madam, please, they use satellite.
They use satellite.
Hello, madam, please, they use live data.
Very good. So that live data, what comes in that live data? How fast or how slow you are walking. All right, so if the ETA before you start is 14 minutes, all right, for you to normal walk. However, instead of walking, say, no, I don't want to walk. So the 14 minutes is for those who want to walk. But now you want to run or even jog. It's not, the ETA is no longer going to be the 14 minutes, but it will be reduced. Let's say 10 minutes, you are jogging. All right. Before it does this, it's going to use live data. And that live data is how fast you are moving from one point to another point. And so it's looking at the rate of change of your distance with time. And if you are talking about something that is changing, rate of change, like we mentioned, any scenario or any activity or anything at all that involves change is calculus. And so GPS not only doing all this recalibration thing alone, but it is using live data. And the type of live data it's using is the fastness level or the slowness level of whatever it is that you're doing, whether it is you are walking or whether you're running or whether you're jogging or whether you're driving. That is what it does. So in GPS, those that want to go into the GPS or you want to go into traffic and logistics, you'll be using calculus as well. That's why I said that if you want a modern IT career, then calculus is going to be your foundation. So calculus is not something weird that you need to have some type of brain matter to be able to comprehend. No, it is our everyday activity that involves change. That is what calculus is. Then in AI, those that will be in AI, we know what AI is, right? Artificial intelligence. How is AI coming in when we are looking at calculus? Most of us, when the semester starts, most of your assignments will be putting it in ChatGPT. Please do not use ChatGPT. There are so many AI modules that we can talk about later on if you are interested to help you understand certain things. Because sometimes in ChatGPT, the answers that you get is very wrong. And so you notice that the first attempt or the first time you give ChatGPT a question, it will give you a solution, whether it is step-by-step solution or whether it is, the final answer solution. Sometimes it's very wrong. But if you know how to go about, the problem that you've been given and get a solution, your next thing is, no, this is wrong. This answer that you've given to me is wrong. What ChatGPT is going to do is that it's going to try and minimize the error margin. All right, so it will minimize the error. This means that there is going to be some form of change or some form of variation in the step-by-step solution that I gave you earlier on. And if you have a system that is trying to minimize errors or optimize profit or whatever solution that you need, it is using calculus. Minimizing means I'm going to look at tiny, tiny bits and then try as much as possible to get the best one. Therefore, in AI modules, they also use artificial intelligence. So for those that want to go into AI, you'll be looking at some variation, how trends are changing, how best you can minimize some errors so that if I get this, if my error margin is, say, 2%, then it's better. But if the error margin is 100%, then it means that your model is not predicting the best outcome. Then those that will be going into energy sector and smart devices or smart systems. In Ghana,
Hello, madam.
No, we can't hear nor see you.
Hello, madam. We can't hear you, even though we can see, but we can't hear you.
It might be a network issue, so we should give him some small time.
it seems Madam is facing some technical challenges, and it seems she's offline.
Or someone is trying to hack you already.
Yeah.
Guys, let's exercise patience. She will join very soon. I think she had a low battery because it's popped up on the
Please,
screen.
the class is still recording. Let's just stop there.
The network.
Okay, boss.
No, my bundle did not finish. I think Vodafone is at it again. You notice? Yeah. Was I gone for very long?
Yes.
Not that
Couple of minutes, please.
Just a quiet for a while.
You said,
They've done their thing again.
and then the thing went
Is
off.
there anyone here working with Vodafone so I can give you an F straight away? Is there anyone here who works with Telecel?
Yes, here.
Please, go register for RESET. Go register for RESET. Vodafone people, the way you are, please go register for RESET. It's an automatic fail. It's an automatic fail. With that being said, let's talk about the telecommunication first. Since Vodafone decided to disappoint me, let's talk about the telecommunication. So for example, as we are having an online lecture now, we are using Zoom. So the amount of data I'm going to use is not going to be something which is a straight path. It's going to have an increment in the amount of data. And so there too, we are going to have calculus as well. Meaning if the server, all right, if the server for Telecel, yes, your people, your server, it's not optimized to handle a whole lot of users on it, then as the number of users increases, there is going to be some form of delay. There is going to be some form of data loss or packet loss. Like there is breakages. As I'm speaking, there might be breakages. A lot of information is going to be lost along the way. There will also be some delay. Some parts you will hear the voice, but as I'm writing, there will be a delay. And then sometimes too, the whole thing will drop because the server is not optimized to handle the amount of load on the network. And also, if I use my device as a hotspot to increase some devices on the hotspot, you notice that as the number of devices attached to your hotspot increases, your data usage goes down, your battery's life goes down, a whole lot of things also go down. So in telecommunication, we can see some scenarios or some settings where things are changing day in and day out. Then in cybersecurity, can someone talk to us about how calculus happens in cybersecurity? What are some of the things that are changing in cybersecurity? Anyone?
We have the two-step verification.
Two-step verification.
Then we have the authentication apps.
Very good.
And something like the password manager.
Very good. And so you notice that the system, all right, so if you want to log on to the LMS, and the system detects that you are doing maybe 5 attempts per minute, what do you think will happen if the system detects from 5% per minute, things change from that to 500 attempts per minute? What do you think is happening?
The system will detect a possible brute force attack, so they will
Very
lock
good.
us.
So there will be, the system will recognize that this is an attack. because from 5 attempts per minute, now you're having 500 attempts per minute. And so the system gets an alert that this is an attack. And so as a cybersecurity analyst, you'll be able to determine that there is some form of change within the number of attempts per minute. So from the 5 attempts, now you have 500 number of attempts. So you can put some more security measures in place to make sure that you don't get attacked. Then those in banking and maybe fintech. Do we know what fintech is? What does fintech means?
No, madam.
All right, so
Madam, it's like
We don't know.
fintech
fintech is
is
a
like
short
a
form of
middle.
financial technology. All right, so fintech means financial technology. What they do is that they put various types of technologies together to help the banking sector. Those days, if you open an account, all right, or even you want to open an account, even it happens these days, you need to walk to the bank. They open the account for you, and then you get a checkbook. Then with the checkbook, they introduce the ATM card. And then after the ATM card, they had the GH link, meaning even if your account is with EcoBank, you have EcoBank ATM card. When you get to any ATM, you can withdraw money, whether the ATM there is Stanchart or whether it is any other bank. Then we have the Visa now. All right. So there are various algorithms. What the fintech are in charge is they put various algorithms together in AI, in cybersecurity, in blockchain. They put all of these algorithms together to help the banking sector. Those days, if you go to the ATM machine, you can say ATM machine. If you go to the ATM, you need your card. Now we have the fingerprint system also installed next to the ATMs. So you can do that. You also do not necessarily need your card. If you have your phone, you can issue a withdrawal. You go to the ATMs and then you click on, I think, the cardless system. This is also a different algorithm that has been put together, right? And so there are various algorithms put together to help the banking sector. But there is one thing that has not been implemented yet. You can use your mobile wallet, you can use your fingerprint, you can use the ATM, but there is one last thing that has not been implemented yet. Therefore, without these three things on you, if you go to the ATM, you will not be able to withdraw money. And that last thing is the facial recognition feature or the iris recognition feature, because that is also unique to you. And so, example, you go to the ATM, you don't have your card, you amputee, therefore you'll not be able to use your thumbprint. You don't have your phone on you to issue the cardless withdrawal system. If you have, an algorithm embedded in this whole ATM system, that can do the facial recognition or the iris recognition, which is unique to each individual, you will be able to have access to, your account and then perform transactions on it. And so as scientists like yourself, I do propose to you that, get an algorithm, write an algorithm that can do the iris recognition or can do facial recognition and see if it can integrate. The word here is integrate, right? Because integrate means you are adding one thing to another thing. That is also under calculus. So you are going to integrate your facial recognition feature to the existing features, which is the one that handles the ATM card, that handles the fingerprint, and then the one that handles the cardless withdrawal. Integrate yours into the existing algorithm, and that becomes the whole, solution to the problem. I call it the problem now, because sometimes you don't have your card, you're amputee, you can use your fingerprint, you don't have your phone on you to issue the mobile money wallet. So if you can do that, you are going to get a lot of money. That is if the banking system will allow you to integrate your algorithm into their algorithm. So that is what they do. Aside this integration of AI models, the blockchain models will help the banking sector. They also manage a bit of fraud. If, as let's say 3 a.m., all right, there is a different behavior exhibited by a customer. At 3 a.m., you start withdrawing or start transferring all the money. Let's say you have 500,000 you saved over the period. You start withdrawing all the 500,000 cedis from your account to another account offshore. They'll be able to detect that this is fraud or you want to commit fraud. Then they issue an alert. You might either get a block on it or some form of extra authentication to know that it's really you that want to do that. So there are lots of disciplines in our field that uses your calculus. And that is what we are going to do this semester. We are not going to approach the calculus on that the pure mathematics aspect of calculus, but on the application aspect of calculus. This means that in our final exam, it is not going to follow the approach of like the senior high, the junior high way of questions where we say differentiate this or integrate that and so on. No. There are two forms of the calculus, one that is looking at the rate of the change and the other is looking at the totality of the changes, all right? And so your questions are going to be in that form. We'll see how the questions will be as time goes on. So some of the things that we'll be doing here are not the straightforward way of mathematics, but the application aspect of the calculus itself. If you develop an app, how will you be able to know that this app is going viral?
And by the number of people who download the app.
Very good. So
or
the number
usage.
of users downloading the app, or even the number of users using the app. And so you will notice that at the end of the day, there are two things you are going to measure. One is the rate at which the number of users is changing. All right. So one will be rate. Maybe the first day, how many number of people use my app or downloaded my app. Second day, how many number of users use my app or downloaded my app. This is what you use to determine whether the app is going to go viral or go viral. The other thing that you can also measure is maybe you want the first 10 days. You can look at the rate at which the app is going viral, meaning the number of people downloading your app. At the end of 10 days, you can also know the total number of people who have downloaded your app. So day one, maybe you had 10 users downloading your app. Day two, you have 20 or 30 users. Day three, you have 50 users. Day four, and so on. If you look at the rate at which people are using your app, that is calculus. That is one aspect of calculus. At the end of the 10 days, you can know how many number of people have downloaded your app. That is also another branch of calculus. All right, so we have one branch of calculus that is dealing with the rate of change of the number of people using your app. Then we have the other branch, which is the total number of people using your app, the cumulative amount. Another example is on the LMS. At the beginning of the semester, we can measure the rate at which students go on the LMS. That is one branch of calculus. We can also look at the total number of students who have gone on the LMS. That is another branch. So there are two main branches of calculus. One branch is dealing with the rate of change, and the other branch is dealing with the accumulation, the total number of users on the app, total number of students visited the LMS, total number of people downloaded your app, and so on. All right, so one branch is what is the rate, how fast or how slow people are using this, how fast or how slow the server can give me a response if I issue a request on a server, how fast or how slow the server can respond. Then the other aspect is, at the end of the day, how long did the server give me a response? If I issue 100 number of requests, how long did it take to give me the response? The other aspect is, what was the rate? First 5 requests on the server, what was the time? The next 10, what was the time? The next 20, what was the time? At the end of the day, if I'm able to know how long it takes the server to give me a response, that is one branch of calculus. The branch that deals with the rate at which something changes is known as differential calculus. Then the other branch, which deals with the accumulation, the total response time, the total number of users downloading my app, the total amount of energy consumed within the day, both 8 a.m. to midnight and so on, the total number of attacks on a network, the total number of users on a type of telecommunication network like the Vodafone, the total number of people I've added on my hotspot, total number of data I have used during the 2-hour lecture. That branch of calculus is known as integration. So both the rate, which is differentiation or differential calculus, and the accumulation, both deal with change. But the way we talk about the change, or the way the changes represent themselves in differential calculus, is not the same as in integral calculus. In differential calculus, yes, the thing is undergoing some form of change. We are looking at the fastness level or the slowness level of the change. GPS is recalibrating your total ETA, all right? So it will look at how fast the person is walking. That is differential calculus. If it accumulates all the total, at the end of the day, you use 18 minutes. That 18 minutes represents the integration. But if it's looking at your fastness level, or within the first 2 minutes, this is the speed. Within the next 3 minutes, this is the speed. That is differential calculus. Within 10 days, we launched an app. If we look at the rate at which people are downloading, so if we look at the rate at which people are downloading our app, that is differential calculus. If we are looking at the total number of downloads within the 10 days, the first 10 days that we launched the app, that is integral calculus. Then in the cybersecurity, if we are looking at the rate at which attacks are happening on a network, the rate at which someone is making an attempt to log onto a network, that rate is what is known as differential calculus. If we're able to calculate the number of attacks on the network within a specific interval, that is integral calculus. So yes, both deal with change, but the way we talk about differential calculus and that of integral calculus are not the same. Differential calculus means how fast or how slow. Integral calculus means what is the total at the end of the day? What is the cumulative? So the word for differentiation or differential calculus is rate. The word for integration means the cumulative, sometimes merging, if it's algorithms that are performing separate things, and we find a way to put all of them together, like the ATM with your card, your fingerprints, your facial recognition. That is merging various algorithms to get a bigger picture. However, if we are looking at the change in some scenarios, the change in trends, change in AI, change in technology, that is differential calculus. So calculus on its own means change. However, there are two ways we are looking at the differential calculus and the integral calculus. Differential calculus means how fast or how slow. Integral calculus means put all the tiny bits together. So there is some form of separation that exists within a system. We are going to merge all of them and get a bigger picture. If you move from Ghana to a different country, we have our own culture. If you go there, you learn their culture. You put the two cultures together, that is integration. But if you're looking at how the rate of change of one culture to another culture, that is what differentiation is about. Now let's look at can someone tell me how we can talk about calculus in terms of mobile money systems? How differentiation, we can talk about it, how integration also features in the mobile money system. Yeah, mobile money. How can we talk about mobile money? And then, yes.
Madam, with the mobile money, when it comes to intra-operability, that is the integration. We are able to withdraw with using MTN, withdrawing in Vodafone, or with Vodacash, you can withdraw if you want to get it in MTN, or send to somebody.
Very good. Yeah, and then, what about integration?
Madam, when it comes to disbursement.
Sorry?
Disbursement, the integration.
Yeah, what about the differentiation? You said that with the integration, now you can use MTN to withdraw from other network. So you have one network can be integrated into another network. And I'm asking how can we also talk about differentiation?
Yes, so initially we were not getting, we can't withdraw anything from mobile banking. We have to go directly to the bank to withdraw. But with mobile money app, we can be here and send money to somebody who is far away from us. We can also receive money from somebody who is far away from us.
Okay.
In terms of business, we can get paid instantly.
Okay. Is there any other?
Yeah.
Okay, madam.
Yes, madam. Can you hear me, please?
Yes, I can hear you. Yeah, I can hear you, Chief.
With the calculus, as you made mention, calculus can come in as when we use it to measure the rate of change of transactions per day or per month.
Very good. Very good. So the rate, all right? So first day.
The rate of change, so that's differential. So that one is termed as a differential.
Very good. What about integral?
So that one is also the total number of transactions made by people that is during the day or the month.
Very good. I love the fact that you guys really understand the calculus from your own perspective. That is very good. Is there any other, those of us who are already in the field of IT, is there any other way you can also see calculus happening in your day activity? It doesn't necessarily need to be you in the IT field. Are there any one of us who can look at our day-to-day activity and say that, yes, this is how we've been using calculus, which is the differential, and then the integral? Is there any other?
Please, I want to add up.
Okay.
I'm with a media house. So, for instance,
is it Vodafone?
Media house. No.
Oh, media house. Okay, very good, very good.
So, for instance, the number of people, our listeners, have been increased. So, I can take in the differential or in the difference, how speed or how fast we are able to reach out to many people or listeners and viewers. Apart from that, with the integral, we can calculate the number of people who are listening, the total number of people, maybe from region, Ashanti region, and other stuff. So
very good.
Yes.
Very good, very good, very good. I love this. I love this. Any other? Because there will be a follow-up assignment, and the assignment is how is let me reduce it a bit. In your own words, all right, how are you using calculus in your activity, in your day-to-day activity? All right, so you can discuss how calculus will influence your future IT career, or even at the moment, what are you in, and how do you see calculus manifesting itself? I think we have heard from the mobile money gentleman, and then we have also heard from the media personality, where the differential calculus will be the rate at which, you can also work in the reverse, the rate at which people tune into your network. And then the integral calculus will be the total number of people who have tuned into your network. So maybe you start with the afternoon, the mid-morning ride or whatever, afternoon ride. The first 1 hour, how many people are tuned in? The next 2 hours, how many? That variation will give you the differential, because it will be looking at the rate at which people are tuning into your network. And then the integral will be at the end of the day or at the end of the program, how many people tuned into your network. Is there any other person here? Where is the Vodafone gentleman? The person who works with Vodafone and is getting automatic F.
Just run away.
Yes, run. Is there any other, those of us who are already either in the field or in a different field, how do we see calculus?
Madam,
Even normal settings, marriages, the rate at which people are marrying is changing. That is calculus. And if we can find within a specific year the total number of marriages, that is integration. So it is not just something that is so abstract. No, it is just something basic as anything that changes itself.
Madam, please.
Those in the death and
birth rate.
Yes, death rate, marriage rate, divorce rate.
Prepaid consuming.
Oh, my brother, say that one again.
Population.
Printing press.
Prepaid, 2 minutes is gone. 2 minutes is gone. Is there a strategy? Is there anyone who has seen a strategy with the prepaid? Because I need a solution.
Because
I think we are all looking for that strategy.
You're also looking for that solution.
Because the Public Utility Regulatory Commission increased their tariff. That is how, yes. So they have it's because of either rule or a constitutional mandate that every 3 months they need to sit down and review our tariff. So in case of water, electricity, other stuff, every 3 months they need to review it. So every 3 months they will go for a meeting with their teams and other stuff. So after then they give the information out that Public Utility Regulation Commission, PURC, they are increasing their tariff. So it's something normal, but just that nowadays people are complaining too much. It seems the tariff we have increase is too high. So people are calling on the government to do something about it.
Yeah, it is true.
Madam.
Yes, please.
Okay, I also work with the National Health Insurance Authority.
Okay.
And one integration that we are having now is that those with Ghana cards can easily use the My NHIS app to register new registration without coming to the office.
Okay.
If you have a Ghana card too, you can easily link it to your NHIS card to access healthcare. Use the Ghana card to access healthcare.
Okay.
At the comfort of your home. So that is what I can also say.
Yeah, and I think with that, it will be easier for you to recognize the calculus aspect, because now you have a system where you can look at the rate at which people are using, whatever you've developed, and then that will be the differentiation. And then when it comes to the integration, you can know the total number of people who are registered over there.
There's also an app that can be used to renew the card, the
Okay, so now you don't need to
anytime it's mobile.
anymore. You don't.
Yes, madam, with the no fee stress policy, so they compare the number of students who applied for the application maybe last year. This year, it will be, or the number of people or the students it will increase. So
It will over them. It will over them.
yes. So it seems the calculus is working.
Yes, yes, they
Yeah.
can know the
Madam,
rate. I think they can use that to implement policies, government policies in the future. Maybe study the trend. The first year, this number of people applied for the no fee policy. The next year, how many people? So if they study the trend and see that the rate at which the number of people applying for the no fees policy is increasing, is going to create a huge demand on the government taxes and the government pocket money. So they might use that to, introduce a new policy that no, we cannot maintain this, and we need to cancel that. And then that is for the differentiate, helping them understand that this is the rate of change of the number of students. Then for the integral will be the total number of students or the total number of applicants at the end of the 10 year or at the end of the office of the governing body that introduced the no fee policy. So yeah, I think that will also come in as the calculus. Yeah, someone was going to talk.
Yes, madam, I was saying the calculus can also come in our public transports. For example, those of us who pick the public transport to work, the rates you pay each day.
Yes.
Then so that will be the differential. Then at the end of the month, the integral will be how much you spend for the whole month.
Very good, very good, very good. I love this. So now you
hello,
see
madam.
that, yes.
Madam, please, you made use of marriage to as example, like the
rate
number of at which people get married, and the number of people who get married in the year.
Yes.
Please, what about the rate at which people get married in the year, and then the rate at which people get divorced at the end of the year?
Yes, that is also differential.
Because
So
the divorce is more.
Which one is more?
The divorce is very more.
How before you get divorced, you must have married.
That's what I'm saying. People get married, and then within the year, the number of at which people divorce is very, very more. That's what I know.
We are not buying that.
Yes. Yeah. So you will
different.
marry in the name of Jesus. Amen.
I'm already married.
You will marry.
I'm already married.
Okay.
Yes.
You will never divorce. Okay. All right. So yes.
Okay, madam.
Yeah.
Madam.
So I think
I'm into software development.
Very good.
And when it comes to, building a website or an application, we usually use some version control to track, the progress. When it comes to, whenever we build any feature or maybe we build something new, let's say for instance today, if you build something, you after building it, we sort of like, let me say, integrate it, something like that. Because let's say for instance, I've already built something. Today you build something new. After checking that everything is right, then you now integrate it into what you have built already.
Very good. Very good. Yes.
So I would say the differentiation will be, the daily features that we build, and then the integration, maybe the full-blown app or the full-blown website.
That is true. That is true. Sometimes if you are to write, as the time goes on, you write an algorithm in Python. So one person will say, okay, I want to do the importation of the libraries. Then another person will say, okay, I want to do the part where the algorithm will do the computation, and the other part will say, okay, I want to do the graphicals representation. At the end of the day, you put all of them together in a specific manner that it will be integration. So one part will perform one function, another part will perform another function, then the last part will perform another function. You put all these variations together, that is integration. So yes, software, yes. Yeah, there's a hand up.
Yeah, madam.
Yeah.
Good afternoon.
As you are mentioning it, I'm setting the exams question now. No.
Yeah, so, madam, please, can you hear me?
Yeah, I can hear you, please.
So, madam, I work at a biscuit factory.
Okay.
Then, we produce biscuits. So, at the end of the day, our differential will be the number of flour we produce, and then our integration will be the number of biscuit that came out from the oven.
Yeah, that is true.
Yeah.
That is so. Maybe first hour, how many did you produce? Second hour, how many? That rate is the differential. Then at the end of the day, how many biscuits were produced? That will be the integral aspect of it. I've not heard from a lady. Are there no ladies within us?
Hello, madam.
Are you a lady?
There.
Are you a lady?
No, please.
Yeah.
Madam, we are here.
Oh, I've not heard from the lady.
The ladies work with Vodafone.
Okay,
They are with Vodafone. So they can't
ladies
talk.
first. So
They are
I will
with
go
Vodafone.
for a lady.
Let me hear from a lady. Any day-to-day activity that involves changes, anything you have done today that has changed itself.
Said the name, talk.
I mean, they are not ready. They are not ready. The guys are ready. So
Sir, madam.
Yes, talk to me. Talk to me.
Madam, I work at the university and we deal with the students.
Yes, yes.
With the students.
The rate of number of applicants within a specific
administration, the population,
very
and
good.
how their utility consumption and
yes.
So
the differential will be the rate at which maybe if the portal gets open, maybe you have 1 week as an applicant to go and apply for a specific course. Day 1, how many applicants? Day 2, how many applicants? Day 3, how many applicants? Then day 5, how many applicants? That will represent the differential. Then the integral will be the total number of applicants at the end of the day. In terms of their energy consumption too, their energy consumption in the beginning of the semester might not be the same throughout the semester. Because at the beginning of the semester, students are now coming in. Not all of them are on campus, so the consumption rate might go down. Then within the first, week to second week, the consumption will start going up because now everybody's on campus. They are plugging in their devices, they are plugging the appliances, the electronic appliances. They are playing video games throughout the semester, so throughout the period. So consumption might go up. Then getting towards the end of the semester, consumption might go down again because now they have trooped into the libraries and the lecture halls to study. So in their various dormitories, they've turned a lot of their devices or they are not even plugged in their device, their laptops and so on. So yes, that would be the differential. And then the integrals will be the total amount of energy they've consumed throughout the semester. So that is how you can see calculus in terms of those in academia. And myself, for example, I can also see calculus when it comes to the differential will be the rate at which students are, attending lectures. It might not be the same. Maybe the first week will not be the same as in the middle of the semester, and then getting to the end of the semester, the rate will keep changing. I'm not going to get the total number of students, attending lectures throughout every single week. That'll be my differential. Then the integral will be at the end of the semester, how many students, attended all the lectures. So when we are looking at calculus, we are not looking at something strenuous. We are not looking at something which is out of touch with reality. We are not looking at something that is not doable. We are not looking at mathematics that's archaic. No, we are looking at scenarios that are changing. Things are changing around us every single day. All right, so that is what we are going to do this semester. Every aspect of the calculus we are going to do is going to be on the application aspect of it. So from now on, if I mention that we are doing differential calculus, It means that we are studying a system that is undergoing change. However, we are considering the rate at which the change is happening. Hello, if you can mute your mic. We are looking at the rate at which. Hello. Oh, please, can you mute your mic? I think he has forgotten lecture.
Miss Grace, your co-host, you can mute him.
Please, can you mute your mic? All right. Hey, please, who is still talking? Let me see. Whose mic is still? Yes.
Madam, it seems like the guy is far away from the.
Yeah, I think
he has finally muted. He has muted.
Okay. All right. So when we say that we're doing differential calculus, it means that we are looking at scenarios undergoing some form of change. We want to measure the rate at which this change is happening. Every 4 years, like I mentioned, there is change in the governance system. So that 4 years will represent the differential. All right. Then the total will represent the amount of terms this governing body was maintained in power. So we are looking at the rate of change. However, when we're looking at integration, we are looking at the total number of people, the total number of users on a particular website or a particular app. We are looking at the accumulation, or we are looking at merging, or we are looking at adding, or combination. And so if you see a scenario where it says we are looking at the rate of change, it means that we are looking at differentiation. If you are looking at a scenario where it says the total or the accumulation or the merge or the added or the combined, then set a scenario is integration. So these are the words you'll be seeing, most especially in your exam as well as in your group work. These are the words that you'll be seeing. Differential means you're looking at the rate, how fast something is changing or how slow something is changing. And then integral means I have different variations. I want you to find a way of merging them to give me a common ground, or I want you to find a way of integrating one algorithm into another algorithm so that I can get a bigger picture. That is integration. Or I have this total number of students on. This is the rate at which students are logging on to the LMS. I want you to find I want you to find the total number or the accumulated number of students.
Tell you, Sagabanka.
Vodafone man, another receipt.
The Vodafone man, it seems Madam will fail her. He will fail him.
Head your hair, when it
In advance.
Thank you. Oh, Charlie, but no one the class they be serious.
Hey, when I tell you something,
Vodafone network, you supposed to improve upon your networks. Abba.
Hey, when I tell you something,
Sam Sherry, welcome.
Rana, we cost rep.
Hello, guys. I beg we close.
No, we no close.
My
Once
network.
it's in session.
The network where they fuck up for Madam inside of here.
Yeah,
Okay.
I think she's having challenges with her network.
Even me, they love it more.
And you say,
Charlie, make questions enter.
Jose,
Make questions enter. Before they ask question, now they hear exams. Then you need the question and maybe start here.
Oh,
by the
be
way,
like,
hello.
be like
Please,
your class, or
let's
this one be the most interactive.
hello. Let's all be mindful. This class is being recorded. Let's all just wait for the lecturer. She'll be back very soon. And those of you using avatars, if you could disable it, it'd be very much appreciated. Okay, so
Then toilet this pass from her.
it doesn't
Avatar
overlay the lecture videos. Thank you very much.
Merci.
So today is Sunday, pan network the freeze like this.
Where is the lecture?
I'm the lecturer.
Hi, class rep. Can you please get in touch with Madam and let us know what is happening?
This Vodafone guy, what be him problem? Charlie, connect madam's internet to.
Please, guys, I was not with you from the beginning. If Madam show any equations and things.
Just hold on. She's joining again. I just switched it.
School ref, I want to speak with you.
I didn't even know I was gone. All right, so we're looking at differential integral, and we'll also be looking at limits because we also want to study the behavior of the entities, the various scenarios as they undergo these changes. And we are going to use functions to study them. We have all seen functions before. If I write down a function, what are some of the things you can recognize in a function?
Madam, please, I think your session ended before getting here.
So you didn't see this diagram?
I didn't see it.
No. There was nothing like this.
But me, sir, I
What
didn't
about
see.
this? What about this?
Nothing of that sort.
No.
We were
No,
at
no, madam, please, you were offline.
Brother, you were offline. We didn't see
Nothing
anything.
showed I was off.
A lot happened.
yes,
So
yes, yes. This is where we got to.
no, no, the first one we were not this one. No.
Not this one, but
No.
here.
No, the other
We were
one.
here.
Yes.
Yes. This is where we were.
Yes, madam, this is where
We
we
didn't
were.
link.
This is
Oh.
where we
We
were.
did not link the differentiation and then the rate. We didn't link it to the unit.
Okay, so so that's what this was. The call was coming through. So differential and integral. All right, so the differential, we know what it means. We can measure it around us in our workplaces, in the house, activities. We want to measure the rate, the fastness level, or the slowness level of the activity as it's changing. Integral means what is the total number. Both differential and integral calculus use a structure known as limit. Limit means the thing is going through change. I want to measure the behavior of the entity that is undergoing through the change. All right, so
It is finished.
Um, um, it seems she's receiving a call. I don't know.